Hey guys, how's it going? Today we have another trigonometry lesson for you. Do recall, trigonometry is all about finding angles and side lengths of right angle triangles. So last lesson we did a lot about side lengths. Today it's all about angles. So given that we have two sides to this triangle and we know it's a right angle triangle, how can we find the angles? So let's start with deciding that this is theta. Okay, we could go with either one, but we just need to pick one to start. So this is theta, which means if this is our opposite, that this will be our adjacent, and this will be our hypotenuse. So which trig operation uses adjacent and hypotenuse? You should know that it is cosine. So katoa means adjacent over hypotenuse. So we put in our values. Adjacent 9.61, hypotenuse 13.6, and we're left with a problem. Well, we have 2 out of 3 values in the formula. We should be able to solve for the third, but we have a cosine of theta. How do we handle that? Well, let's just recall something you already know about solving for unknown variables. So let's say we have this situation. 5x equals 15. Okay, well, how do we solve for x here? This is 5 times x, our variable. So we need to do the opposite operation. What is the opposite operation of multiplication? It's division. And by how much? The same amount. So here it's times 5, so we need to divide by 5. Whatever we do to one side, we have to do to the other, because we have to respect this equal sign, the most powerful symbol in math. So, respecting the equal sign, we do the same thing to both sides. Dividing both sides by 5 gives us x over here, isolated the variable, and our answer on the other side, in this case 3. So, think about the steps we did. We saw what was happening to the variable. We did the opposite or the inverse operation, which left us with the variable all by itself and our answer on the other side. Over here we have x squared. What's the opposite or the inverse operation of squaring something? Well, it's finding its square root. So if we find the square root of x squared, we'll be left with x. But make sure we do the same thing to both sides. If we square root one side, we have to square root the other side. So on the left we have our variable isolated, and on the right we have our answer. So if there is a flash, there is a reverse flash. They're the same but opposites. So that's what we're going to think about for isolating theta. We need the inverse operation of whatever trigonometric rule we're using. So let's describe this triangle to start. We'll say this is theta, right? It could always be either one, but this will be our 90 degrees, which would make this our hypotenuse, our opposite over here, and our adjacent side down here. What we need to decide is how do we go the opposite way of finding the sine of something. Okay, so the sine of theta is the opposite over the hypotenuse. We need to isolate theta. Look on your calculator, and you may have to look in the second function area. So hit second function, and then where it says sine, there'll be another button which will either say arcsine, or it might say sine with a -1. Both of these are called arcsine, and if we were to spell them out, it would be ARCSINE, the full word arcsine. Just like you have an arc nemesis. But these are not evil functions, they're just inverse. So, if we do the inverse, if we do the opposite of sinin theta to the sine of theta, then we'll just have theta left. So, I'm going to write in the arc sine of theta, and you can write arc sine like this or arc sine like this. I prefer this way. So the arc sine of the sine of theta will just leave us with theta. And whatever we did to one side, we have to do the other. So we're going to find the arc sine of this ratio. And so that is what we're left with as our answer. So given that we were left with, or that we had, the opposite and the hypotenuse, we can solve for an unknown angle theta. So the same is true, or the same method is true for the other two trig functions. The cosine of theta is equal to the adjacent side over the hypotenuse. And so we can look on our calculators for arc cos, the arc cosine, which is also, it might look like this, cosine with a -1 as an exponent. And so finding the arc cos of cosine of theta will leave us with theta. Will leave us with theta right there. And whatever we do to one side, we have to do the other. So the arc cos of the adjacent side divided by the length of the hypotenuse is what we're left with on the right. So arc cos adjacent over hypotenuse. I think you'll see a bit of a pattern here. There's only one left. Let's describe the tan function. There is indeed an arctan, which is represented a very similar way, tan with a -1, or arctan written out. And so we can do the same thing here. Tan of theta is opposite over adjacent. So if we're solving for theta, we could use the arctan function to isolate that variable and be left with theta. And whatever we did to one side, we have to do the other. So the arctan of the opposite over the adjacent is what we'll be left with on the right. So, 3 new functions, 3 new formula, but you don't have to remember these formulas. All you need to remember is your first 3, and then that if we're solving for our theta, this is how we do it. We use the inverse function of whatever we're using. So if it's sine, we use arc sine. If it's cos, we use arc cos. So you don't need to memorize these formulas. You just need to know how to go from here to isolating theta. So let's do an example. So here's a right angle triangle. We're not given the angles except that this is 90. So what are we given? This is the hypotenuse. So we're given the opposite side, and we are given the adjacent side. So which one of our functions uses those two values? It's tan. Tan of theta is the opposite over the adjacent. If we plug in what we know, the tan of theta is equal to 19.1 over 12.5. Perform this division. You punch this into your calculator. you're going to get 1.528. So this is nice. All we have to do is isolate theta. And how do we do that? First, we use very neat lines to show your teacher marking your test what you're doing, so it's all an easy progression. And then you take the arctan of both sides. So the arctan of the tan of theta and the arctan of 1.528. We'll leave you with theta on one side, all alone, and punching this into your calculator, you're left with 56, rounded up, 56.8 degrees. So this value here, theta, measures 56.8 degrees. Now, if we wanted to know the other value, we could use trig again, or we could just say 180 minus 90 minus 56.8 and get our answer. So that's as complicated as you can get, except if you put it into a problem. So let's read this problem and try and figure out a strategy for solving them. So a 6-meter long ladder, it leans against a building. If the ladder makes an angle of 60 degrees with the ground, so the ladder and the ground make a 60-degree angle, how far up the wall does the ladder reach? Part 2, how far up the wall is the base of the ladder? Round your answer to 2 decimal places. So this is just a problem. We haven't seen it before. How do we attack it? Well, the first problem-solving strategy that we always say is draw a picture, just so that we understand what's happening. So what do we have here? A 6-meter long ladder leans against a building. Okay, so I'm going to draw that. I'm going to say there's a ladder here. Oh, I won't use it. I'll use the dotted line for the ladder. You can imagine those are the rungs of the ladder or something. So there's the ladder. It's leaning against a wall. And, well, we could fill in the ground. So we could assume that the building is making a 90-degree angle. So, okay, we drew a picture and discovered, oh, it's a 90-degree triangle. This must be a trig question. Trig, not trick. So what do we know? The ladder makes a 60-degree angle with the ground. So this value here is 60 degrees. What else do we know? Oh, it's a 6-meter long ladder. So the ladder is 6 meters long. All right, so we have a value here. How far up the wall does the ladder reach? So we want to know the height of this wall. So we can call that the height. And we want to know how far is the wall from the base of the ladder. So here's the wall to the base of the ladder. So we want to know this distance, this base right here. So how do we start this? Well, what are we given? We're given an angle and hypotenuse. Let's start with the first one, and we're asked to find this value here. What value is this? Is this adjacent or opposite from theta, our angle? It's opposite. So we're looking for a trig function that involves an opposite side and a hypotenuse. And that would be our sine. So the sine of theta is equal to the opposite over the hypotenuse. Let's sub in what we know. The sine of 60 degrees is equal to the opposite, which we don't know, over the hypotenuse, which is 6. So if we solve for the opposite side, we get 6 times the sine of 60 gives us our opposite. Plug that into your calculator and you will find 5.20 is our answer. So the answer here, the height, this is supposed to be an h, the height is 5.20 meters. So that's part 1. Let's do part 2. Find the distance from the wall to the base of the ladder, well, we can use this same angle again. Now we're dealing with the adjacent side. We have adjacent, we have hypotenuse, we actually already have the opposite as well. So we could use tan and go opposite over adjacent, or for simplicity's sake, I'm just going to use hypotenuse again. So the cosine of theta is equal to the adjacent side over the hypotenuse. So cosine of 60 is equal to the adjacent side over 6. So 6 times the cosine of 60 is our adjacent side of our triangle. Plug this into your calculator and you will find you get an answer of 3. So the distance from the ladder to the wall is 3.00 meters. Now, why did I put a 0 here and 2 zeros here? Well, because the question specifically told me to round my answer to 2 decimal places. So I could write 3, numerically that's the same, but the question has asked me to round it to 2 decimal places, so I'm going to be even more specific and say it's not 2.9 rounded to 3 or anything like that, it's really 3.00. It's that precise. So I'm respecting what the question has asked me. And that's your second problem-solving tip of the day, is once you're done, go back, read the question part of the question, the part with question marks, the last bit, and make sure you've actually answered it. Have I answered both parts of the question? Yes. The height of the ladder and the distance to the wall is there. Did I round my answer to 2 decimal places? Yes, I did. So I'm okay to move on. So always check back. Once you're done, read the last part of the question again. Did I actually answer the question? Okay, new question. You're mapping out a hiking trip for a new spot in the state park near your home. On your map, you know that you're supposed to go to a course which ends with you having moved 2.5 kilometers east and 3 kilometers south. Calculate the angle that you need to walk with respect to due east. Okay, so let's just make a picture, just like we did before, to show off what we know. So we know that we're using the coordinates east, south, west, and north. We're using that system to describe directions. 2.5 kilometers east. Well, okay, we went from here to here. East, we'll say, is going right. That's the convention. So we went from here to here. That's 2.5 kilometers. Okay. Next, we went 3 kilometers south. All right, so a little longer and straight down. This is 3 kilometers south. So we went from here over to here and then straight down. We want to calculate the angle that you need to walk with respect to due east. So if this is our starting spot, we want to know what angle do we need to walk at so that we end up in the same spot. In other words, everything's askew. In other words, we're trying to find this angle here. This is the angle with respect to east, which is a horizontal line. What angle do we need to walk at so that we end up at this spot here? So we've constructed a right angle triangle. Okay, we've recognized that it's a right angle triangle. We can use our trig rules. So let's see what we have. We have, with respect to theta, an adjacent side and an opposite side. So what trig rule uses those two side lengths? Well, you're right, it's TOA. So the tan of theta is equal to the opposite over adjacent. So all of these start, and all of your solutions should start by writing out your formula in full. This formula here. Once you've done that, let's sub in our values. So the tan theta is equal to 3 over 2.5. All right, we're solving for an angle here, which means what? We've got to use an inverse trig function. It's tan of theta, so we got to use arctan to solve for just theta. Whatever we do to one side, we have to do to the other. And there you go. So we'll be left with theta is equal to the arctan, of 3 over 2.5. So it'll be the arctan of 1.2. Plug that into your calculator, and we get 0.876. So we must walk at an angle of 0.876 degrees. We could say south from east. Now, there are other ways of indicating where the angle is, but the point is you have to answer the question, which is calculate the angle you need to walk with respect to due east. So you can say from east we need to walk south 0.876 degrees, or any other way you like, but you do need to answer that question. One last example. A tower, 2.84 meters high, must be secured with a guy wire anchored 5 meters from the base of the tower. What angle will the guy wire make with the ground? Now, if you aren't familiar, a guy wire is the wire that sort of supports the tower. It comes out at an angle, attaches to the ground so that the wind doesn't blow a very tall tower over. So, how do we start all of these problems, really? Let's draw a picture. So, we need a tower. I'm going to draw a beautiful tower. Isn't that a nice tower? It says it must be secured with a guy wire anchored 5 meters from the base of the tower. All right, so here's our wire. Ran out of trackpad. So imagine that's a perfect line. 5 meters from the base. So let's put in our values. Here is 5 meters from the base. The tower is 28.4 meters high. And we can assume that the tower goes straight up out of the ground, so it's a 90-degree angle. Great, we found a 90-degree angle, or a 90-degree triangle, I should say. We can use our trig functions. So what is the question asking? What angle will the guy wire make with the ground? So which angle are we looking for is the question. Are we looking for this one or that one? No, we're looking for that one. We're making, which one does the guy wire make with the ground? So here's the guy wire, here's the ground, and it makes this angle. All right, let's look at what we have. We have the one right beside it, the one adjacent to it, and we have the opposite one. Okay, another tan function. Now, they won't always be tan. It just so happens that we've seen a lot of this today. So here is our trigonometric ratio to work with. Let's sub in what we know. Tan of theta is equal to its opposite side, okay, 28.4, over the adjacent side, which in this case is 5 meters. So So the tan of our angle theta is, if you plug this in, 5.68. We're solving for theta, which means we need to do the opposite of tan, so arctan. Whatever we do to one side, we have to do the other. Boom. We're left with theta on one side, and we're one step away from our answer on the other. Plug this into our calculator, and we find that our answer is 80.02 degrees. So, to write our, what is the question asking? What angle will the guy wire make with the ground? We can say the wire will make an angle of 80.02 degrees with the ground. And that's it. So, just to review, we made a picture that helped us see our triangle, very important. Once we can see our triangle, then we can decide, okay, what do we have? Opposite, adjacent, hypotenuse. That tells us which of our trig functions to use. Once we have that, it's just a simple matter of plugging in our values and solving for the unknown, whatever that might be. So I hope you enjoyed this trig review. See you in the next one.